So in history recently, we were talking about America in the early 1800s and how people disposed of their waste using chamber pots. And a custom that was formed out of that time was that if a man and a woman were walking together on the sidewalk, the man would always walk on the outside of the sidewalk, nearest to the street, so that if someone threw a chamber pot out the window with all their waste, the man would get hit. So my question is, assuming that the chamber pot is being thrown from 15 meters off the ground and at a speed of 10 meters per second, how far away is the man standing so that he will be hit by the chamber pot? You want to remember that there are two vectors going on here. There's the vertical vector, with gravity affecting the chamber pot at 10 meters per second squared, and there's the horizontal vector. The chamber pot is being thrown at 10 meters per second, and so it will continue at a set rate of 10 meters per second for however long it takes for the chamber pot to hit the ground. First, we want to figure out how long it will take for the chamber pot to hit the ground. So we can treat this as if it's just being dropped from the window. It's not being thrown because gravity affects the chamber pot separately than the horizontal velocity. We can start by using the v squared equals initial velocity squared plus 2a change in x, right? And we're trying to find the final velocity so we can find the time it takes to drop. We don't know the final velocity. We know the initial velocity, which is 0 in this case, right? Plus 2 times the acceleration, which we're going to say is negative 10, times the change in x, which we're going to say is negative 15, because that's the distance it's dropping. So solving for all these variables, we have 300 here. So that means right before the chamber pot hits the ground, it's going to be traveling at 17.32 meters per second vertically, downward. We can use the equation x, distance traveled, equals average velocity times time, and solve for time. We know the distance traveled is 15 meters. We know the average velocity is going to be 8.66 times t. And then all we have to do is solve for t. And that comes out to be approximately 1.73 seconds. So now that we have that information, we can use the amount of time that it takes for the chamber pot to hit the ground after 15 meters, and we can apply that to the speed. So we know that it's moving at 10 meters per second constantly until it hits the ground. We can multiply 10 times the amount of seconds it's traveling, which is 1.73, and that gets us 17.3 meters. That is how far away the man needs to be standing from the chamber pot for him to get hit.